Again, question number 13. Aircraft departs a point 4 degrees north, 170 degrees west, and flies 600 nautical miles south. Right. So, which hemisphere is this whole thing happening? Northern hemisphere, right? So basically, think about it. Northern hemisphere, the meridians are somewhat in this fashion, right? Southern hemisphere, the meridians would be somewhat like this because it's converging to the poles, right? So if you have this understanding, think about it. You are actually on 4 degrees north, 170 degrees west, and in what direction are you traveling first? The very first travel is towards south, right? So basically, and then so you're traveling south first, and then you're traveling east, right? So you can see I need more space like this. So if I draw this diagram here, then I won't have space to draw it because it goes off, right? So we have to have that idea in mind. So I'm somewhere here, which is say 4 degrees north and 170 degrees west. Perfect. And therefore this is 4 degrees north, and let me take this as 170 degrees west meridian. Therefore this point is point A, and from point A I'm traveling 600 nautical miles south. Now what is meant by traveling south? Along what am I traveling? Along meridian, right? So north south is always along a meridian, right? So I'm traveling from point A, I'm traveling south means I'm traveling along the meridian down all the way for 600 nautical miles, and therefore you will end up reaching a particular parallel of attitude, right? What is this parallel of attitude? Now you can find this straight, right? Since I'm traveling along a meridian, it is a great circle. It's a semi-great circle or a great circle where you can apply the 1 minute is equal to 1 nautical mile conversion. Therefore 600 nautical miles is equal to 600 minutes, which is equal to 10 degrees. 60 divided by 60, so it's 10 degrees, right? So from 4 degrees north, when you travel south by 10 degrees, where will you reach? Say
14.
Think about it. You're on 4 degrees north, you're traveling south by 10 degrees. Will you reach 14 degrees north? What if I'm traveling north from 4 degrees north by 10 degrees?
6.
Talk louder, because since you're confused, at the same time your volume is low, I'm not able to pick up what you're saying.
6 degree north.
6 degree north. So 6 degree north is here.
South.
Yeah, you're telling me the answer to this part, 6 degrees south, which is correct. Yes, 6 degrees south. Therefore, this is 6 degrees south. You cross the equator. So by the time you travel by 4 degrees, you are on the equator, right? So equator is somewhere down here, right? And now from the equator, you're traveling further down, and then you will reach by 6 degrees. You will reach 6 degrees south. So first 4 degrees you will reach the equator. Total is 10 degrees, which means I have to travel 6 degrees more, and I will reach 6 degrees south. The diagram is not very appropriate because the diagram should be more like I'll just draw a bigger diagram here. This is 170 degrees west, right? And I'm initially on 4 degrees north, which is somewhere here. So 4 degrees north, this is the point A, and from point A I'm traveling south by yeah, very good. I'm traveling south by 10 degrees. When I travel by 4 degrees itself, I'm reaching the equator, another 6 degrees to south, and that is why you end up reaching 6 degrees south. So it's here, 6 degrees south. This is west, east, north, south, and this is the equator. Perfect. So the first travel is from point A. Sorry. Yeah. The first travel is from point A all the way to point B, and that is 600 nautical miles, so 600 minutes. And since I'm traveling on a great circle, it is 10 degrees. Now from B, what am I doing? I'm traveling 600 nautical miles to the east, right? So now I'm traveling 600 nautical miles to the east, and I will reach a different, so my latitude is not changing. Towards the east means I'm traveling along a parallel of latitude. East west is all along a parallel of latitude, and therefore my latitude is not going to change. My chill out is 0, but I'll be having a chill on. I will reach some other longitude, correct? This is point C. Now what is the next direction from point C? I'm traveling 600 degrees north, 600 nautical miles north, right? Where do you think will I reach if I travel 600 nautical miles from C north? So traveling north means I'm again traveling along a meridian, right? So when I travel 600 degrees north, where do you think we'll reach?
On 4 degree north.
On 4 degrees north. This is along a great circle again, which means 600 nautical miles is nothing but 10 degrees. So it's pretty clear that since I'm traveling along great circle again by 600 nautical miles towards north, what is happening? What is the change happening? Is there a chillong here? There's no chillong here. There's just a chillat. And what is a chillat?
That's 170.
It's again 10 degrees. Chillat, change in latitude is 10 degrees, right? In which direction is it changing? Towards north, right? Where will you reach? You'll again reach back at your 4 degrees north. Yes, what is the next direction? What is the next track? You're traveling 600 nautical miles now to the west. So towards the west means you're traveling along a parallel of latitude again, right? So from D, if I travel 600 nautical miles, where do you think will I reach? Will I reach before? Will I end up short of A, or will I reach exactly at A, or will I cross A? Short, yeah. Even from the diagram you can kind of make out, because this is 4 degrees north, but this is 6 degrees north, right? So 4 degrees north, the distance between the same two meridians is actually departure is actually more than the departure along 6 degrees north. Departure decreases as you move towards the poles, right? So this 600 nautical miles, if I take straight here, is you're going to end up somewhere here. This is your final track. So your aircraft is right here now, after traveling 600 nautical miles towards the west. Make sense? Now look at this. So what is asked in the question? You're asked to find out your final position, right? There are two ways by which you can do it. Let's do the first way, and then let's look at a simpler way straight here. You have to have a rough idea about the globe, and then you understand that you're crossing the equator and you end up reaching 6 degrees south. Is it clear so far? Yes. To the dot. Right, now what is the question? You have to find out your final position. So what is your final position? How will you say a position? To say a position, you definitely need the latitude. So what latitude is your final position on? It's again on 4 degrees north. Now that will not be sufficient to completely define a position. You also need the longitude, which is right here. Yeah. Will you be able to find this longitude? You are on 4 degrees north, departure of 600 nautical miles. You can find it. But before that, you have to find out what this longitude is. So that you can find out from this departure here and this parallel of latitude, you can find out this longitude. So let's find that out here. What is the departure equation?
Geelong in minutes.
Departure in nautical miles, it's always in nautical miles, is equal to change in longitude in minutes multiplied with, so it's cos of cos of a particular parallel of latitude. Perfect. Now what's the departure? Departure is 600 nautical miles. That's equal to Geelong, you have to find out in minutes multiplied by cosine of 6 degrees, right? Now Shillong in minutes is equal to 600 divided by cos 6. And how much is that? So you are on 170 degrees west. You're traveling easterly for 10 degrees 3 minutes. So basically, to understand longitudinal changes or Shillong, the easiest way is to draw a top view. You can take this as a prime meridian reference, and this is the anti-prime meridian. 170 degree west is here. And you're traveling for 10 degrees 3 minutes. So will you cross the anti-prime meridian? If you travel by 10 degrees itself, so what direction is easterly direction?
Yeah.
Easterly means it is, what direction is it?
East.
Yeah, top view, easterly means what direction is it?
Anti-clockwise.
Anti-clockwise. So will you cross the anti-prime meridian?
No.
No, you're 170 degrees west and you're traveling towards the east by 10 degrees 3 minutes. So where will you end up?
160.
Yeah, 160 degree. If you take the 3 minutes as well, it will be 159 degrees and 57 minutes. Right?
Yeah.
West. Right? Therefore, this is 159 degrees 57 minutes west. Perfect. Now, you got this Shillong. Now, through this longitude, you're traveling towards north, which means the longitude is not going to change, but in latitude is changing. You ended up on 4 degrees north. Now, from 4 degrees north, you're traveling west by 600 nautical miles. You know what your initial longitude is. If you can find the Shillong, then you can find the final longitude, right? And therefore, the position of point B. So let's find that out. Again, the departure equation, departure in nautical miles is equal to, yes, what is it?
Shillong into minute.
Into
Shillong
minutes.
in minute into cos of that.
Into cos of latitude, right? Be very careful with this being in minutes as well as a trig function, a trigonometric function for departure is cos, right? So departure is 600 nautical miles. Shillong in minutes multiplied with cos of 4 degrees. So Shillong in minutes is 600 divided by cos 4.
601.
601 minutes, and that is again approximately equal to 10 degrees and 10 degrees and 1 minute.
1 minute.
Right? What direction is the change happening? The change is happening towards
West.
west. What was the direction here? It was towards east. This is west. So where will you end up? You are on 159 degrees 57 minutes. Now you're traveling west. So from 159 degrees 57 minutes over here, now you're traveling back. You're traveling westward, which is a clockwise direction, by
Clockwise.
10 degrees and 1 minute. Where will you end up?
One.
Very close to 170 degrees, right? Very, very close to that. So it's around 10 degrees 1 minute. It will be 169 degrees 58 minutes west, right? You see, this is 4 degrees north, this is 6 degrees north. That is why the departures are not, the Shillong is not that different. This is 603 degrees, this is 601 degrees. You can see it's almost close because the latitudes are, the values are very, very close, 4 and 6. Only thing is, one is in northern hemisphere, other is in south, right? If the latitude have been different, like one is 60 degree, other is 10 degree, there is a definite change or difference between the Shillongs. All right, so what is the final position of E? E will be, it's on 4 degrees north and 169 degrees 58 minutes west.